Hi guys, my name is Josh
My name is Shireen Lorena,
and we're about to discuss
programming language and its paradigm.
First, we need to know what are those generation programming languages we have, which are first generation language, second generation language, third generation language, fourth generation language, and lastly, fifth generation language. First generation language or machine language is also called low-level programming language because they were used to program at its very low level. The advantages of first generation language are
The second generation language comprise assembly languages that use the concept of mnemonics for the writing program. In the assembly language, symbolic names are used to represent the opcode and the operand part of instruction. Advantage of second generation language. Third generation languages or high-level languages were designed to overcome the various limitation of the first and second generation of programming languages. Advantages of third generation programming language. Fourth generation language or very high-level languages. The languages of this generation were considered as very high-level programming languages. It required a lot of time and effort that affected the productivity of the programmer. The fourth generation programming languages were designed and developed to reduce the time, cost, and effort needed to develop types of software applications. Advantages of fourth generation languages.
lastly, the fifth generation programming language or artificial intelligence language aka AI. The programming language of this generation mainly focused on constraint programming. The major fields in which the fifth generation programming language are employed are artificial intelligence and artificial neural network. Advantages of the fifth generation languages.
First of all, I would like to thank Josh and Sherlyn for discussing about generations of programming language. And now I'm here to talk about the programming paradigms. Without further ado, let's go.
We need to know what is a programming paradigm. A programming paradigm refers to a style or method of writing a program. Now, let's assume you ask 10 people to create an omelette. They would each prepare it differently, of course. Which of the following is the typical method for making an omelette? A similar issue will arise if you ask 10 persons to complete the identical program. They will each complete it in their own way. So, programming paradigms are different techniques for writing your program. It is critical to understand how we will write a program. Understanding the program paradigm is necessary for that. When selecting a programming language for building a program or software, we must ensure that it supports the programming paradigms. Now, why do we need a programming paradigm? One of my favorite coding quotes is, "Any idiot can create code that a machine can understand." Skilled programmers produce code that humans can understand. Considering building software with 10,000 lines of code with a group of people. What happens if they all create the software in their style? First and foremost, the program's complexity will rise. The program's readability and structure will suffer. It will be tough to test, and updating the code will be incredibly complex. What will happen if everyone writes your application using a set standard? We can reduce many of the problems. A programming paradigm will assist us in resolving all problems. Thus, the programming paradigm offers a unique standard for developing programs and software. Types of programming paradigm. The two sorts of programming paradigms are imperative programming and declarative programming. The two types of imperative programming are procedural and object-oriented. There are two types of declarative programming as well. logical, and functional. Let us examine each of these points in further depth. Imperative programming, the word imperative implies command. Imperative programming tells the computer how to complete a task by giving a list of commands or instructions in a specific order. The order of instructions is significant in imperative programming. In this example, we are giving the computer line-by-line instructions on how to add two numbers and subtract two numbers. Procedural programming. In procedural programming, we divide the problem into smaller sub-problems. We often refer to this structured approach. A procedure is a chunk of code that performs a specified task. Data and logic are separate entities in procedural programming. Here, have two procedures, add two numbers and subtract two numbers. The main procedure will call this sub-procedure to add and subtract numbers. In object-oriented programming, we will use classes and objects to create an entire program. The whole program will run depending on object interactions. Objects are real-world entities with properties and behavior. The classes act as the object's blueprint. Classes describe the characteristics and behavior of objects. In this example, you can see that we have three classes: calculator, addition, and subtraction. The addition class is in charge of adding two numbers. The subtraction class is in charge of subtracting two integers. So, the calculator class will call the addition and subtraction classes to add and subtract two numbers. Here, all three classes interact to produce a result. Declarative programming. In declarative programming, we tell the computer what to do rather than how to do it. We shall always focus on output or result in declarative programming. In this sample code, we are telling the database what we want rather than how it should do. Functional and logical programming are the two main subtypes. In functional programming, we will split the entire program into two functions. Each function takes some parameters as input and returns the output. JavaScript is one example of a functional program. Here in the example, we have three functions. The addToNumber function adds two integers. The subtractToNumber method subtracts two integers. So, these two functions have two parameters like I, j. It returns the output. So, the calculate function is responsible for adding and subtracting two numbers. Logic programming. Logic programming is composed of facts and causes rather than instruction. In logic programming, we will build an entire program based on the notation of logical detection. Logical programming uses its knowledge to arrive at a true or false conclusion. Example: Prolog language. In this example, we tell the computer Socrates is a man, and we say all men are mortal. Then we ask the computer, is Socrates mortal? The computer will then use its knowledge to reply yes. Conclusion: in the previous section, we learned how to write a program in different programming styles. The same program has rewritten it in different ways. For example, functional programming. We split the program into small functions. In a procedure, we divided the entire program into individual procedures. In object-oriented programming, the whole program is split into objects. So, it is clear that using a programming paradigm reduces the complexity and increases the program's maintainability.